In this video here, we're going to be looking at equivalent fractions. So your learning goal is that hopefully you understand what an equivalent fraction is by the end of the lesson, and also that you can compare fractions using equivalence. So I've got a quick question here for you, and I had a pizza party the other day, and they had my 4 friends over, and we made homemade pizzas, and they cut them up into their own sort of style of slices, and this is what they ate. So I've got the example here. They ate these things here. What they ate was in green, and what was left over is those pizza symbols there. And the question is, who has eaten the most or the least pizza? I want to leave that question there for you. So if we had to write these as fractions, I can see Trevor, there was 2 parts in total, and he ate 1. Jackie, there was 4 parts in total, and she ate 2. Jared, there were 8 parts in total, he ate 4. And Talia, there were 6 parts in total, and she ate 3. Okay, so as you can see, we've got different fractions here, but the reality is, and you can sort of see this just visually, they've actually eaten the same amount. But the way that we express this formula, or the way they express these fractions, give us an idea, and we call this equivalent fractions. So even though they have different slices and the numbers there are different, for example, you've got half, 2 fourths, 4 over 8, etc., they're actually equivalent fractions, and that's what we're getting at here in this lesson. So the first part is, what is an equivalent fraction? I'll get you to write these 3 parts down and why they're important. So fractions that can be simplified, okay, ones that can be simplified to the same basic fraction, that's what an equivalent fraction is. An equivalent fraction is a fraction that marks the same place on a number line, and we're going to look at an example of that very soon. And also, equivalent fraction can represent the same value but written differently, and we've got an example of that here with the same value but it's written differently. A good way to understand how equivalent fractions work is to use what we call a fraction wall. Now, these are sort of the list of all the fractions from a half up to 16, 1 over 16. And what you want to look for is you want to use this as a pattern, and you're trying to find a line. So let's start here with a third. Okay, I'm going to use this point here on a third. Now this means 1/3, as 1 out of the 3 is coloured. If I follow this line down, I can identify equivalent fractions that sort of align up with that. Remember how we said here, fractions mark the same place on a number line? That's the same thing kind of with understanding equivalent fractions. So for example, 1/3 is the same as 2/6. So I can see 2 out of those coloured in. 1/3 is also the same as 3/9. And I can also say that 1/3 is the same as 4/12. So by using this fraction wall, we can see how equivalent fractions work and sort of how they are represented. Now let's do a bit more examples here, and we'll get into a bit more of the nitty-gritty. So how do we actually create equivalent fractions? And you need to do the same thing, we've got 2 different ways that we will do that. The first one is that equivalent fractions are created by multiplying the numerator and the denominator by the same number. Okay, and that's the important part. You're multiplying both the numerator and the denominator by the same number. If you want to find an equivalent fraction the other way as well, they can also be produced by dividing the numerator and denominator by the same number. And we use, this is an important part there to understand, because we're going to be looking at simplest form very soon, and that's one way that we do that. But when you're creating an equivalent fraction, you multiply the top number and the bottom number by the same number, or divide the top and the bottom by the same number. So let's look at an example. Alright, so we want to find 4 equivalent fractions for 2 over 3. So if we write 2, sorry, get my pen. If we write 2 over 3, we want to find 4 equivalent fractions. So the first one I'm going to do, other than 1, I'm going to times the top number by 2 and the bottom number by 2. And what that will equal will give me an equivalent fraction of 4 over 6. Okay, so I've times and multiplied the top number and the bottom number by the same number, and that has created an equivalent fraction. Now I need to find 4, so let's do 3. Let's pretend, so we're starting with this number. I'll clear this out. Now I'm going to multiply, so I've multiplied these by 2. I'm going to multiply the next part by 3. Sorry, bad writing there. Alright, so 2 times 3 equals 6. 3 times 3 equals 9. So now I have another equivalent fraction. Now I'm going to multiply the same number there by 4. Both numbers by 4. That will again give me another equivalent fraction. 2 times 4 equals 8. 3 times 4 equals 12. And finally, if I do the same process again by multiplying both the top number and the bottom number by 5, I have 10 over 15. So now I have 4 equivalent fractions, and I've simply just done that by multiplying the top number and the bottom number by the same number. So to multiply the numerator and the denominator by the same number. Now sometimes we're going to get questions where we want to check for equivalence. Okay, we want to see if numbers are equivalent or not. And we're going to use the same method here. We're using that understanding. And we're going to find that by seeing if they multiply the top number and the bottom number by the same number. Now when we're doing this, a little hint here is that equal sign, as we all know, means equal. When you have that equal sign with a line through it, that means not equal. So that's how we're going to express our answer if it's not equal. Alright, so we have 1/3 and 3/7. So can we see if these are equivalent fractions? So what I need to do, I need to be able to multiply the top number and the bottom number by the same. So for me to get to 1 to 3, I need to multiply this number by 3. That means I must multiply this number by 3 as well. But what that actually gives me is 3 over 9. So I can therefore say that 3 over 7 is not equal. Okay, so I'll do the equal sign with that line in the middle. Now let's check our next one. So we have 4 over 5 and we have 20 over 25. Let's see if it's equal. So for me to get to 4 to 20, I need to times 4 by 5. Will give me 20. That means I need to times the bottom number by 5 as well, because that is our rule. 5 times 5 equals 25. And that is what it says there. So therefore, these two numbers, or these two fractions, sorry, are equivalent. So any questions, make sure you write them down so we can cover them over in our lesson. But again, the key things here that you understand is that we have multiplying the numerator and the denominator by the same number will give us an equivalent fraction, and also the reverse will happen. So if we have a big number, we can also find by dividing the top number and the bottom number by the same number, we'll also get an equivalent fraction. Thanks, guys.